Okay, now it's recording.
All right, so number 21, I got 2.055.
Let me find which. I have so many windows open. Yes, that's what I got as well.
Okay.
Me too.
All right, then estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. Okay, so estimate the standard deviation. Again, I don't know how to do that. I don't know what they're...
So it's just the standard deviation. So it's the normal formula. So it's just the mean divided by, well, okay, so this one's a little more complicated. But when it says, we'll assume, oh, wait a second. Yeah, okay. We'll assume 1.59 per million is the value of the mean minus 2 away from the standard deviation. Same with other way. Okay, so how did I do that? I can't remember. How I decided to do it. And I took the mean minus. Well, let me see if I did this right.
Did you figure this one out, Michael, already?
No, I need to work through it.
Okay.
Oh, I know how. Okay, so basically, I did it by taking the mean and subtracting it from, well, I subtracted the 1.59 from the mean and got 0.48465. So,
So 1.59 is the value you got, and you subtracted the mean from that.
yes.
Okay, so 2.055 minus. Now, why did you take the 1.59 versus the 2.52?
Because you have to do it either way.
Okay.
And so we have that, but then we still have the fact that it's we still have to account for the 2 times the standard deviation, right? So then I divided it by 2 to get the standard deviation.
So 0.233.
And I did that because if you were to take the mean, which is 2.055, and do that formula, that's what you would get. I just did it backwards.
Okay.
We weren't ever given like a formula to figure this out. I just, logically went backwards. And that's the best I can figure it out. I could be wrong, but I don't know how else you would do it.
Okay.
Okay.
Does that make sense?
Yeah.
Okay.
All right, so then between what two measured nitrate concentrations do approximately 68% of the data values lie? So we're just taking the 2.055 and subtracting.
One standard deviation.
So subtract 0.233. So it's 0.1822 and 288. Okay. Okay. What's the value of the mean of the standard normal distribution?
Okay, and that's just the mean. And while you guys discuss 25, I'll be right back.
Okay. So, Michael, just to go back 24, the value of the mean, that's going by the rule that the mean of the parent population is the same as the mean of the standard normal distribution, correct?
Correct.
Okay, good. All right, what's the value of the standard deviation of the standard normal distribution? Isn't that this?
What is the value of the standard deviation of a standard normal distribution?
I don't know what they're asking. I don't really know what they're asking.
Honestly, I don't really know what they're asking either. A standard normal distribution.
So it's saying when you have, okay, well, I'm pretty sure, well, maybe I just don't understand the question. But I think the answer is in 3. Okay, I'll be right back.
Okay.
I'm gonna pull this stuff up really quick and see if I can find that. I'm not really sure what it's asking either, so.
Yeah.
So is this just another way of asking what the standard deviation is
Well,
for the water?
if you look at lesson number 7's homework assignment, they had a similar question, and the formula of that was taking the standard distribution and dividing it by the square root of the number, which she was saying was 1.59. I don't know which number you would take. It's somewhere between 1.59 and 2.52.
Well, that would make more sense than just taking the standard deviation. Let me pull up that homework.
Okay.
'Cause that sounds like a really good place to start.
Yeah.
And someone is not happy.
No, for sure.
That's all right. It's getting close to 1:30. That's nap time for most people, so.
That's for sure. Me too. So if I calculate this according to what I'm reading on lesson 7 number 5, I'm calculating it to be 0.185.
Okay, I'm back. What are you guys talking about?
Number 25. If you look on number 7, the homework assignment for lesson 7, number 5 on lesson 7, it's talking about the standard deviation of the distribution of. Oh no, that's standard means though. I don't know.
Okay, let's see.
I'm still stuck on like the last 2 weeks. I keep forgetting that we even had lessons 4 weeks ago. I don't even remember any of that now.
Well, I think this is standard deviation. It's a measure of the spread. Okay, let's see. What's the question asking exactly?
What is the value of the standard deviation of a standard normal distribution?
See, it makes me think it's from the last couple of weeks. Let me see. just want the answer to that question.
I see a lot of questions from previous homeworks asking the value of the standard deviation of a standard distribution of the means. But I don't see one that's talking about just the standard normal distribution.
Less than 5 is normal distributions. So maybe I'll find it in here. Oh, wait. And maybe it talks about, let's see. Oh. 68, rule, the 68, 95, 99.7 rule. The value of the mean. Okay, I'm not sure about 24, but I think 25, 68%. That would be my guess.
So you're thinking it's a percentage?
I was asking for the value, which means it's a number. So I'm not. That's why I'm thinking it might be that. Does that make sense?
Yeah.
Usually, if it's the answer is in a percentage form, they would have a percent sign. But I don't know. That's just me. That's my logic on how to take tests.
Well, normally that's true. Normal distribution. So a normal distribution, though, is saying that 68% rule, 68, 95, 99.7 rule applies. It doesn't mean we necessarily use it, but I'm going through lesson 5 because that is normal distributions. That's what it's called. So let's see. Oh. Okay. So in the story it says a standard normal distribution has a mean of 0 and a standard deviation of 1. So I think that's what it is. The value of the standard normal deviation is 0. The value of the standard deviation of the standard normal distribution is
Would be what? I lost you the tail end there.
Sorry, 24 is 0 and 25 is 1.
Why 0 on 24?
Because under it just says so in lesson 5 I have to why I'm doing. In lesson 5 summary it says a standard normal distribution has a mean of 0 or deviation of 1. That's just what it is.
That's what it says.
Okay.
Oh, goodness.
Does that make sense?
Well, that makes sense because here I am thinking 24 and 25 revolve around question 21, and it doesn't.
Right.
Okay, that makes more sense. I'm still going by the info on that one. Okay. All right. So we're on 26 then?
Yes.
Okay. The admission committees for most masters of businesses require the graduate management admissions test as part of the application. GMATs are normally distributed as mean of 542.3 and standard deviation of 120.54. The minimum GMAT score required is 500, but it's rare for students with scores less than 600 to be admitted. Okay.
Now I think
Now it says use this information to answer question 25 through 31.
It's all right. It's not.
I
Must have been a typo.
think it was a mistake.
Okay. All right. So, what's the probability the randomly selected student will score 542.3 on the GMAT? So we have to find the z-score for that and use a probability applet, correct?
Yeah.
So z-score is going to be the value.
There isn't a value we're using. It's just the mean.
Okay, so 542.3 divided by the standard deviation.
Right. Except then I get a ridiculously high number to put in the probability.
Yeah, 4.449.
The probability applet does not like it when I put it in there.
Yeah, so the probability, that makes sense because the probability would be then 0.000006. Right?
No, it's 0.0004. Or there's 6 zeros in front of the 4.
See, I got a 6.8274 E minus 6. I got for the z-score, I got 4.499. Is that what you got?
Sorry. Does that answer even make sense?
Well, it does because it's required to get a 500 to get in. Huh. That would be pretty rare for someone to get score above a 542, even though you have to have a 600 most of the time to get admitted. So maybe that's a little low.
Yeah, that can't be right. It can't be.
No.
But I don't know how to do it, because that's how you do everything else. Like,
I think we're supposed to have a value when we're calculating the z-score. I think we need to take the value. Well, if it's asking for, shouldn't we use the value of 500?
No, because it's asking if they score above 123. So that's the value we use. That we're not supposed to mean because it is the mean. I don't understand.
I don't know either.
It can be the best without a problem. And they make sense.
Mm-hmm. I honestly think, since they're asking, I don't know. This is my feeling is that we would take the value of 500 because you have to have at least that much to be admitted. Minus the 542.3 divided by the standard deviation.
Because the probability should be higher. So the probability that someone will score 542.3 should be higher than the probability that a randomly selected student will score. Well, no, it should be about the same. Never mind. Below 600 is what it's saying.
See, if you're going on the probability that they'd score, I don't know.
What do you think?
I honestly would take the value of 500 minus the 542.3 divided by the deviation as the z-score, which gives you a probability of 36% getting above the score of 542.3.
I suppose it could happen like that.
I don't know. Because if you look at the one below that, number 27, then you would take the value of 600.
Minus 542. Yeah.
And that's about 50%. 48%.
Right.
For 27, I got 68%. It's 600.
It's asking for below 600.
Yeah.
Yeah, I got 68.
Okay.
I got 68% too.
Yeah,
0.664.
0.64.
You're thinking of the z-score, Michael, right? 48%, 0.478. That would be your z-score.
So are we going with the 37 on 26?
Yeah, except you have to round to the nearest tenth, so it'd really be 40% or 0.4. Number 26, you have to round to the nearest tenth. This is 0.36.
Oh. Weird, because the rest of them were doing to the third. Okay.
I know.
Let's see. If I did that, I got a z-score of negative 3.51, and the probability was 637.
On which question?
26.
So which numbers did you use? The 500?
Yeah. What did you do again?
I did 500 minus 542.3 divided by the standard deviation.
That's what I did. I don't.
And I got negative 0.351.
Right. It's asking if who will score above 542.3.
Oh, above. Right. So that would be right. So 0.3628 is the probability. Right?
Because above is the middle and the right-hand side.
I don't think it's the middle, too.
It's because the z-score is negative. So you have to do it from that number.
Let me think for a second here. But 542 is the mean. That's going to be the center part. We don't want that center part. We want above that center part.
It doesn't. That has nothing to do with it. So for z-score, you negative. I'm going to stop hitting the Play-Doh against. Okay, you got it. needs to the z-score is negative. So you take the number up to the right if it's asking for above. So you take it from that point. No, hush. Sorry, does that even make sense?
Yeah, so the z-score is negative, so anything above is, so you're taking the middle and above.
Mhm.
If the z-score is positive, then you're taking the middle and below.
No, if the z-score is positive, you just take the right, not the middle.
So when are we doing just the left?
It's below a negative number, a negative z-score.
Okay, so it's a negative z-score, but it's asking for above, so it's both middle and the right.
Yes.
Is that right? Seem right to you, Michael? There? Do you remember that? I remember watching some video on that, but I can't really remember now.
I'm gonna be honest,
Oh, I think your sound cut out there, Michael.
Yeah, I couldn't hear him at all.
Oh, he's gone. Hey, you back, Michael?
Can you guys hear me?
Yeah.
Yeah.
Okay, so did you hear what we were talking about for the probability app?
Yeah. For the most part.
So does that make sense to you if the z-score is a negative and it's asking for a number above something, you take the middle and the right, shade it?
Yeah, that makes sense.
Okay, so then that would be a 60%. So 0.6
3.7.
on, right?
Mm-hmm. 6 is 0.637.
And so then on 27, are we taking the number 600? Right?
Yeah, so 642.3 divided by 140.54, whatever that number is.
Okay. And I got 0.479
So
the
then you
z-score. Oh, you cut out there. So I'm shading to the right of that.
No, you're asking below, so you're doing to the left.
Oh, below. Below, right. But just the left, not the center then.
Well, no, the z-score is positive that time, isn't it?
Yeah.
And to the left of the z-score.
So 0.316.
That's above. Below.
So I'm shading the center and the left.
Yes.
Okay. 0.684.
Yes.
Okay. So now then when we do the above,
it's just to the very right.
Just to the very right,
Yep.
0.316.
Mm-hmm.
Okay. Is that what you're getting, Michael?
Mm-hmm.
Okay. All right, so find the GMAT score that corresponds to the 10th percentile.
So do you remember how to do the percentiles?
I just watched an video on that. Now I'm trying to remember it. So you put in your 10%
At the top.
in the area,
Yep.
right?
Yep. And because
And
the
then
percentile is anything to below, you just have
Right, anything below 50% is to the left. So we have 0.099, or I guess if we're rounding, round to the nearest whole number.
well, no. Okay, so that gives you the z-score, and then you have to fill it in the formula to find the GMAT score. So you're gonna have the z-score equals the value.
It's cutting out.
Sorry, so it's going back to that formula where it's the z-score formula, but you're substituting numbers to find the value.
Okay, I took notes on that. So you're going to have, So you're going to have x equals z-score times the standard times the value, or plus the mean. Sorry. X equals z times standard plus mean. That's the formula I have when I watch the video about percentiles. When we watch, if you go back to, I don't know if you guys watched the online meeting with Brother Balls.
I need to.
I did that, and he covered those, and that was the formula. So when you're trying to
Well,
find,
it's a z-score. You're just rearranging it. So let me just think through that. Hold on. So yeah, x equals
it should be, this is what I calculated based on the formula that Brother Balls was giving us concerning percentiles. The number, the 10th percentile would be 655. That would be the GMAT score.
Not what I got.
Okay.
Michael, what did you get? Okay, I'll be right back. I need to and recalculate.
Okay.
No? Okay, I'm back. Sorry about the craziness.
No problem.
Okay, Alex, I can't help you right now. Okay, so okay, so what was the Z-score for 10th percentile?
The 10th was negative 1.282. And I did calculate that one wrong.
Oh, okay, so what did you get?
I got 345, rounding to a whole number.
That's still not what I got. I got 388, so...
Okay, what formula are you using?
Well, I'm just doing the Z-score formula and working backwards. So what I have is negative 1.282 equals x minus 542.3 divided by 20.54.
Oh, so you're taking the mean. I wasn't doing the mean. I was doing the number of 500. Maybe that's the problem I'm having.
Oh, you need the mean.
Okay.
That's
So
for sure
let me recalculate that then. Okay, so you're right. I got 388 on that one.
Okay, awesome.
And then 655 for the 90th percentile.
That's 697.
697, all right. Same Z-score, right, but only positive.
Yeah.
Oh, yeah. See? My numbers are hitting the wrong thing. I'm doing it over and over. Okay. 97. I got that too.
Okay. You may want to use a calculator and not your phone for the exam.
Yeah. I am going to have to do that. All right. We lost Michael. He texted us, but he said go ahead and keep going.
Okay.
All right. Find the third quartile of the distribution of the GMAT scores.
First.
Find.
Did you skip?
Oh, yes, I did. First quartile. Okay, so
that's just 25%, remember?
25% of the mean, correct?
No, it's just 25%, so you're just doing the... Alec, I need you to be quiet, remember? So instead of 10 in the area or 0.9 in the area is what I mean, or 0.1.
25%.
0.25, yeah.
Okay. And are we shading the center then? Oh no, it just shades it for us.
Uh-huh.
Okay. Okay, so
You have to do the formula again.
Okay, so the same formula with a different Z-score.
Yep.
So did you get a Z-score of 0.319?
I don't remember.
Well, if you're putting it in the probability outlet.
So we say 0.64.
0.674? Negative 0.674, right? Because it's below 50%. I don't know. Am I getting confused on that?
No, that's
Negative 674? 0.674?
Yeah, so what you need to do is make sure that it's already, like, highlighted where it's supposed to be. Zoe, knock it off.
I got 461 on that one.
Yep, that's right.
Okay. So now we want the third quartile, which is 0.75, which is the same z-score, just positive. I got 624.
Yep. That's what I got as well.
All right. Consider a simple random sample of 15 students. What's the mean of distribution of sample means scores for all such students? So the mean of the sample means is going to be the same. So it's going to be 542.3.
Yep.
Yay, I remembered a rule.
Good job.
All right, what is the standard deviation of the distribution of sample mean scores for all such samples?
So do you remember how to do that one?
No,
So that's
I
when you
don't.
have the, let's see. It's the value minus the mean divided by the standard deviation divided by the square root of n.
Okay. Okay, so let me figure that one out. So we need the square root of 15. All right. So the value we are taking is
Oh, sorry. It's not value minus mean. You just take the bottom denominator. So the standard deviation divided by
okay.
the square root of 15.
Okay. I got, let's see, round to 3 decimal places. I got 31.123.
I think you did parentheses wrong or something. I got 17.424.
Okay, hang on.
They do it as well.
Huh. Standard deviation of 120.54. See, all right. Let me pull out my calculator. I don't know how to use the calculator very well. That's the problem. So I'm taking 120.54
Well, I might be wrong.
divided by
You're right. I was wrong with him. 31.123.
okay, because I was confused on that. Okay, 31.123. Okay. All right, then what is the probability that sample mean score for a random sample of 15 students will be greater than 600? So we still need the z-score on that.
Yeah, so you...
Is that the z-score then?
No, that's the standard deviation.
Okay,
So
the
you still have to
z-score
calculate it.
using the same formula though? I mean, or isn't it just the square root of?
No, it's the whole formula. So it's the value minus the mean.
Okay. What's the value though? What value are we using? 600?
600. Yes.
Okay. Divided by.
The z-score I got was 1.855.
That's what I got. 1.854.
Yep.
With a probability of 0.032.
Yep.
Okay. Alrighty.
Should we submit it?
Yep.
Makes
Here
me
goes
nervous.
nothing. I know. Ooh, 97%.
Oh, good. Let's see. What did we miss?
Number 4.
What? What's number 4? Not put 100 as a parameter and 112 as a statistic.
I put. Oh, I was only picking one answer. So I did
Oh.
112 as a statistic. Stupid.
Yeah, see,
Okay.
we fixed wrong, and I knew we would.
Yeah. But everything else we got right. So you got 100% then.
No, I missed 26.
26? Let me see what I got on that. I got that one right.
You did?
Yeah, 0.6.
Well, the nearest 10th. Gosh darn it. What 3 decimal points?
Yeah.
Shoot. That's annoying.
Yeah, we're under the nearest 10th. Okay. All right, so that's good, though. I mean, we did good. I still don't understand some of it, so obviously I'm going to have to go. I'm going to make a whole sheet of notes, I think.
Okay, sounds good. I'll post this.
All right. All right. See ya.
Okay.
Hey,
Bye.
see you Thursday at 10:30?
Yes.
Okay, bye.